at the last part of quadratics, writing a quadratic function in completed square form. Now, we have already seen completed square form when we did quadratics first time round, and that's when you have a quadratic that's written in the form of x minus a all squared plus b. Okay, and we mentioned that it was called completing square form, and I did say back then, just wait until we get to the algebra of it to understand how we get to that stage. So really, when we have a function written in completed square form, what that allows us to do is it allows us to tell, first of all, the actual coordinate of the turning point and the nature of the turning point. Okay, whether it's a maximum turning point or a minimum turning point. Okay, so really the second part of this should not be new to you. All that should be new here is actually taking it from the trinomial form and putting it into the completed square form. And it is really, really simple. Okay, all we do for that is follow the instructions in this grey box here. Okay, so to do it, first of all, we need to make sure that it's in the form of x squared, x, and then the number. So all we do is we divide the number in front of the x by 2. We put this inside the square bracket with the x, and then we square the bracket and then subtract the number. We square the number inside the bracket and then subtract it on the outside. Okay? So really it's a case of half the middle term, drop the x, make it a square bracket, and then take away the square of the number inside the bracket. Okay? So let's take a look at that then. So first of all, example A, we have x squared plus 6x plus 1. So I'm going to follow the instructions. I'm going to divide the number in front of the x by 2. So then that's going to give me plus 3 inside the bracket. Okay? When I do that, what I do is I take with the square here, I put the x here and I take the square and I put it outside the bracket. So really I'm writing the first two terms as I'm dropping the square and then halving the middle number. And then put the plus 1 on the outside. And in order to actually complete the square, what I then need to do is take away the square of the number inside the bracket. So the number inside the bracket is 3. So if I square 3, I get 9. So I'm then going to take away 9 on the outside. I always, always, always subtract the number that's inside the bracket. So therefore that gives me x plus 3 all squared. 1 take away 9 gives you minus 8. And that's it in completed square form. Okay? Now remember, you can always self-check this. If you expand your brackets and simplify, you should always be able to go back to the original function. Okay, so let's do that. You don't have to do this, but let me just prove to you that this is the same as what we have. So I'm going to write this as x plus 3, take away 8. So that will give me x squared plus 3x plus 3x plus 9 minus 8, which gives us x squared plus 6x plus 1, which is what we had. Okay, so you don't have to do that, but it's good if you want to just check that you've done it right. Part 2, it says, state the coordinates of the turning point. So again, we've done this before. When you have a quadratic that's in this form, the turning point is just the opposite of the number inside the bracket, and then the number on the outside. So the turning point is going to be minus 3 minus 8. Okay? Right, let's take a look at the second one. So we have x squared minus 10x minus 15. So do the same process, half the middle number, drop the x, take the square up. So that will give me y is equal to, open bracket, x minus 5, close bracket, all squared, take away 15. And then I want to take away the square of the number inside the bracket. So if I look at the number inside the bracket, the number inside the bracket is going to be minus 5. And if I square minus 5, I get positive 25. So it's going to take away 25. So then simplify, and we get y is equal to x minus 5 all squared. Minus 15, take away 25, would give me minus 40. I'm not going to go ahead and expand it. You can do that yourself just to check. Let's get the turning point. So the turning point will be 5 minus 40. Okay? Let's take a look at example C. So same idea. We're going to halve the middle number, drop the x, take the square up. So I get y is equal to, open bracket, x minus 2 all squared, plus 1. Then I'm going to take away the square of the number inside the bracket. Minus 2 squared is 4, so I'm going to take away 4. So that gives me y is equal to x minus 2 all squared. 1 take away 4 is minus 3. The more you do these, the more you'll get quicker at them, and you'll be able to do them within seconds. So therefore, the turning point, remember, opposite of the number inside the bracket, so it's going to be 2 minus 3. And the last one. Okay, this is slightly trickier just because we're halving an odd number, so we're going to get some fractions here. We do the same thing, so it'll be y is equal to x plus 1.5 all squared plus 2. Then I want to take away the square of 1.5. So either you would know what that is, or you work it out in a calculator. So 1.5 squared is going to be 2.25. So that gives us y is equal to x plus 1.5 all squared. 2 take away 2.25 gives me minus 0.25. Therefore, we have the turning point to be minus 1.5 minus 0.25. Okay? That is completing the square.